Shut up, drunkies. Smoke the mouth, not the meth. Keep your cells and your teeth. Word. So let's remember what we're doing here. We're building the equation of life from scratch using reason and logic. And in the last video, I talked about topology. Topology is the mathematics of morphing an object into another object, morphing a shape into another shape, turning a ball into a square, turning a donut into a coffee cup. When you turn a ball and a square have in common that there's not a hole through it. A donut and a coffee cup have in common there's one hole through it. And you can do this for anything that has holes in it. If it's 100 holes, it can be morphed into a shape with 100 holes. But it can't be morphed into a shape with 99 holes. So in other words, I can't take a coffee cup and make a sphere because the hole's still fucking there. And in general, math does this, like I'm trying to do in this series and in a little tour of mathematics here. Math teaches you something simple, and it all adds together to form something complicated, because as humans, we're not very good at breaking complicated shit down into simple things. So math sort of helps me do that. It helps me make tough decisions. If I'm making a tough decision with my family or my job, I can break it down into little teeny tiny components and look at each component separately and then make a decision on each of those little components and add it together to form the big complicated decision that I need to make. And of course, alcohol and drugs diluted that shit for a lot of decades. But in this video, we're going to talk about coordinate systems. So what's an exponent? An exponent is a little number above and to the right of another number. So we have a number x and we have some other number up here, b. Let's say x equals 5 and b equals 2. This equals 5 times 5, which equals 25. Pretty easy stuff, I hope. In mathematics, they like to abstract things and generalize, just like I did with that x raised to the b. But what exactly is multiplying a number by itself? So we have a number x times x times x times x times x 5 times. This equals x to the 5th. And anytime you see a number like this, there's always in the upper right hand corner a 1. So whenever there is no number, there's a 1 there. So for this to be consistent, which is a mathematical term for it needs to make fucking sense, we can say that x times x times x times x times x equals x to the 5th, which means these ones above each x were more or less added together. 1 plus 1 plus 1 plus 1 plus 1 equals 5. And another way to look at that is if I were to bust it down like this, I could do these 3 x's were x to the 3rd, and I'm going to bring this times down right here, and I got these 2 x's for x squared, and this comes to x equals 3, x raised to the 3 plus 2 equals x to the 5th. So this property is very important to understanding coordinate systems. Now, what's a dimension? A dimension is anything that can be measured. We live in 3 dimensions. I have my width, my length or my depth, and my height. We actually live in 4 dimensions because time can be measured too. So I'm taking my length, width, and height and moving it across the room. It takes me a certain amount of time to get over there. Therefore, it was a 4-dimensional thing going on. I was moving over there in time and it took me 3 seconds to do it. That's why we live in 4 dimensions. But there can be any number of dimensions. Cosmology is looking at string theory right now, and it is in 11 dimensions. And you can have 1,000 dimensions, 1,000,000 dimensions, and this is not anything that we can visualize. But let's say that I have a line, like so, and I'm going to call the line x. And this is a 1-dimensional line. In other words, it just goes left to right. And it has every number in it. So if I start here at 0 and go this to 1 to 2, and it goes forever to infinity, and if I go this direction, -1, all the way here to -infinity, this is a 1-dimensional line, and it represents every number there is. period. So it's the real numbers. And the real numbers are every number you can think of. Pi, the square root of 2, 3, 9, the square root of 9, which is 3. Anything is a real number. So mathematicians label this an R, and this is a one-dimensional line on the x-axis, so it's a 1 above the R, just like that. That says it's a real number line in one dimension. Now, let's draw another dimension. Boom. We're going to label this dimension, the vertical dimension, y. And right here, we're going to put a 0 and a 1, all the way up to infinity, all the way down here to negative infinity. And this is also a real number line. It represents every number that exists. So it is also an R1. All right? Now you can probably imagine where I'm taking this. If I take R1 and I multiply it by itself, this must, according to the law of exponents, equal R1 plus 1, which equals R2. This would mean I would need to put that x-axis and that y-axis together somehow. And you will recognize this. The xy coordinate axis. So if I take a number x and I take a number y and I put them together like this, I get some point up here in what's called the plane. Pretty simple shit. You're probably used to that. So now I've established this plane of all points x, y. You're used to that. You have probably seen a line going through it. You had to find an equation like y equals 3x plus 2 that represented all the points x that satisfied the equation that gave you a point y. Now, there's another way to look at this axis and this coordinate system of the xy plane. Instead of looking at it as a product of an x value and a y value, we're going to look at it in vector notation. So let me draw another one. Now I have an xy plane. Here's my value 1. All right. I'm going to highlight this distance kind of thick and put an arrow there. And in the y direction, I'm going to do the same thing. That's a 1. Now we know that's the point 1, 0 on the x-axis, and this is the point 0, 1 on the y-axis. If I just stack those two, okay, I can make it a vector. So this is equal to the vector 1, 0. It means I go in the x direction, 1, and I don't want to go in the y direction at all, 1, 0. Vice versa for this. And there's a name for these two, unit vectors. And the reason they're called unit vectors is because they're equal to 1. The one in the x direction is called I hat. And it's an I with a little fucking hat on it. And this is called j hat in the y direction. And so I can say that I hat is equal to the vector 1, 0, and j hat is equal to the vector 0, 1. So now, to go anywhere I want to on the x-axis or the y-axis, I just need to multiply that vector, that matrix, 1, 0 or 0, 1 by any number I want. Let's say I multiplied I hat by the number 3. So this would be equal to 3 times the vector 1. And all I'm going to do is I'm going to multiply 3 by this and 3 by this. And of course, that's going to equal 3, 0. So therefore, the vector 3 times I hat is going to go right here, and that's going to be a vector. I can do the same thing for j hat. Let's say for j hat, I multiply it by the number 2, and that's going to take me up here. Now I'm going to connect these two just like I did in the xy coordinate plane that you're used to in high school, and I'm going to draw a line to it, just like that. So this is going to be equal to 3 times I hat plus 2 times j hat, and that's going to equal the vector 3, 2. And there we have, right there, the vector 3, 2. when you're dealing with coordinate systems, and boy do I wish I had somebody to tell me this, because when I started learning mathematics a little over 4 years ago, I really struggled understanding this vector notation and all this crap, and why the hell did any of it matter? But here's why it matters. Let's say I have this plane of xy, and right here I have my vector I hat equals 1, 1, 0, and right here I have my j hat equals 0, 1. And I have this curve in the plane. Let's say I'm looking at something flying through the air. Let's say at this point, the object is right there, and at this point, the object is right here. And I want to track the object like a radar in an airplane. I can draw a vector to it. This is called a position vector. And if I drop a line straight down to the x-axis and straight over, fucking this up, straight over to the y-axis, I can see I have triangles here. There's a triangle here, and there's a triangle here. So therefore, in essence, I can understand this object's position by analyzing this triangle, which is really what calculus is. It's a bunch of damn triangles everywhere, adding their hypotenuses together, whatever. We're getting into that later. But now I want to connect these two objects like this. Boom, boom, boom. So now I have this position vectors that are tracking its movement everywhere. So I wanted to fire a missile at it. Well, my position vector in the computer is tracking the plane's movement through the air, and therefore it's guiding the missile there. All right? That's one way to look at the plane that's different than you're used to. There's another way to look at this. We're going to move the coordinate system because we can, anytime we want to. Now we're going to put a coordinate system smack dab on these objects, just like this. And I can analyze this object with these vectors. The mathematics of analyzing an object in and of itself is called tensor calculus, and it's kind of like the mathematics of differential equations. And shout out to my boy right here, Pavel Grinfeld. He wrote this great book on tensor. This guy is a fucking genius, BT dubs. Math of the Beautiful is the YouTube site if you ever want to go see math explained very simply. That's a good place to go. But 3 Blue 1 Brown is another place to go while I'm on this YouTube rant of where I learned all my mathematics. And of course, Khan Academy is the place to go to find out anything quick in like a 6-minute video if you need something explained. So those are the 3 I usually go to: Khan Academy, 3 Blue 1 Brown. Although Grant Sanderson at 3 Blue 1 Brown sort of does higher abstractions so you understand it, like I'm trying to do. And then, of course, Math of Beautiful with Greenfield, I hope I'm saying that name right, is more of the explanation deep in, along with Khan Academy. They're 3 really good sites. Recommend them to your kids if you're looking for YouTube sites other than mine. But in any event, I'm putting these coordinate systems on these objects themselves. And I'm going to draw that line again and connect them like this. And at each point, I want to analyze the object's movement right here. Well, now these vectors, while you have kind of, you can picture this vector here as being an x, and this as being like a negative y value down here. There's another vector here that's important. It's the one that goes like this, that's tangent to the curve. And remember, anything that's tangent means it touches the point once and only once, just like that. Okay, so there's this vector right here that's tangent to this curve, and it's a part of this coordinate system. So now you can imagine if I was using I hat and j hat to describe this vector, what could this vector possibly represent? Could it represent its direction, which is sort of over and down, because that's what this object is doing, and the vector itself that's tangent is, say, represents its velocity? And that's exactly what this coordinate system is telling us. It's telling us this vector right here, its length is its speed. And this vector right here, that's perpendicular to it, represents its curvature. That's getting crazy. that's getting into some serious vector calculus. But just understand the point here is that these vectors in this coordinate system no longer represent a distance to something. They represent actual values themselves, like speeds. So therefore we have a coordinate system. We can analyze an object from an origin that we choose, or we can put the origin on the object, and each axis coming off of it describes something about itself. Say it's the money in your money in the stock market, and your money is moving through the stock market, and your investment advisor calls you and says, hey, your money's gaining steam right now. Well, we can imagine that if you have money in the stock market, and here's a coordinate system, and let's just say that this coordinate system, and he says your money's doing good, so your money is going up right now in this direction. Let's just say this x-axis here represents time, and time is moving forward, and this represents how much money you got on the y-axis, and this is saying that your money's doing good as time goes forward, and this rate right here. Well, this magnitude of this vector is going to be how much money you're gaining at that moment in time, and there's a coordinate system here on the object itself that you can use to analyze how much it's gaining with time. And of course the goal is to say this curve is going like this, but let's just say your money starts to go downhill, and over here now your money is going down. So you can see, hopefully you're seeing that in coordinate systems, you can put them anywhere, you can analyze anything, and as you can see, as we do this tour of mathematics and coordinate systems and how I constructed it using exponent properties, that we're going to apply this to that equation later on in life as we zoom in to the decisions that I made and looked at the vectors that, well, got my fucking nuts crushed. Holla!